So the next speaker for this session is Dr. A. Padmakar. Has he joined?
I'm here, Dr. Shukla.
Okay. So I would like to formally introduce Dr. A. Padmakar. Dr. A. Padmakar is a senior engineer and vice president at D. Golier and McNaughton, Texas, United States. He joined D. Golier and McNaughton in 2016 as senior engineer in the Reservoir Studies Division. Prior to joining D&M, he worked for many years as a staff research scientist and senior reservoir engineer with Chevron. He earned his undergraduate and in chemical engineering and from master's degree in chemical engineering from reputed IITs. He received his doctorate in chemical engineering in 2003 from the University of Texas at Austin. He has published and presented a number of articles at SPE conferences and in SPE journals. He served as a program committee chair for the 2008 SPE Improved Oil Recovery Symposium and was also invited to speak at the 2004 SPE Advanced Technology Workshop on gas condensate performance. In addition, he also worked for a while at RGIPT for short duration and then he went back to US to work there. With these words, I would like to invite Dr. Padmakar to speak on 5 current trends in petroleum engineering. Dr. Padmakar, please.
Okay, thank you, Dr. Shukla. I want to share my screen.
Yes.
Can you see my screen?
Not yet. Yes, no, not yet. Just.
How about now?
No, not yet. Is he presenter? Do you see a share button on your screen?
Yes.
I think something is coming now. Yeah, we got it.
Do you see it?
Yeah,
yeah.
Do
you see my? Yeah.
Perfect. Yeah.
Okay. I'm going to put it in. How about now?
Yeah, it's perfect.
Okay. Good morning, everybody. Thank you to RJPT and the conference organizers for inviting me to give this talk. In the petroleum industry, we follow these trade magazines such as JPT and, of course, LinkedIn to stay current with the events that are going on in the energy sector. And recently, we've been seeing several transformational and trends in these publications. So when Dr. Shukla invited me to talk at this conference, I thought that would be an apt talk to share with the audience. I also noticed that the theme of this conference is about new and alternative energy sources. So many of the trends that we are seeing have been discussed in quite a bit of detail in the last couple of days, and they're going to be discussed in the last day of this conference. But however, what I hope to bring to you with this talk is a perspective of someone who is practicing in the oil and gas and how we see these trends from our vantage point. I'm going to skip the slide. It's about myself. I'm interested in consulting, industrial research, academic teaching, so a broad spectrum of interest. So coming to the topic of my talk, so the main current trends that we are seeing when we look at these trade publications, and also when we talk, when we go to these conferences and all, what we are seeing, of course, energy transition, that's the big one. I mean, that's all this whole conference is also about. There have been some very good discussions that have happened on that. And since we are in the petroleum industry and we're a form of energy, that's a topic that's coming up in our industry quite often. Then we are hearing about carbon capture, utilization, and storage, more related to environmental aspects and reducing CO2 emissions. Also, geothermal is something that's coming back. We're hearing a little bit more about it. And of course, we can't talk about current trends without talking about the pandemic and its impact on everything, actually. And of course, the last one I have is data analytics and complex reservoirs, or in other words, data analytics in complex reservoirs. Data analytics is a very popular topic across the board, and it's not just petroleum engineering. You hear about it in all disciplines these days. And finally, I have a few takeaways from my experience in the oil industry over this, and hopefully it will be useful for some young engineers getting started. So let's dive into it. And right off the bat, I want to talk about a little bit about energy transition. I am going to stay very on the 30,000 level because this has been discussed in quite a bit of detail. But the idea here is transition to cleaner energy sources. So having said that, I wanted to start off with this energy landscape. This is a very good landscape that Lawrence Livermore National Laboratories, they put out. This is an estimated US energy consumption in 2020. It's about 92.9 quad. A quad is basically equal to about 10 power 15 British thermal units. And if you're accustomed to oil units, it's about one quad is about 183 million barrels of petroleum. So the US consumed about 100 quads in 2019, but because of the pandemic, it was about 92 in 2020. So the main thing I want to talk from a petroleum engineering perspective from this one is, as the energy transition is concerned, we're hearing a lot, like the previous Dr. Professor Dinesh Srivastava said, we're hearing a lot about solar and wind, and as in the news a lot. But if you look at this, the solar and wind kind of feed into electricity generation. So that's a completely different application than what petroleum is different and generally used for. Petroleum has more industrial applications like petrochemicals and all, which really cannot be easily substituted using any of these other sources. And then petroleum also goes into transportation, jet fuels and whatnot. So that also cannot be easily substituted using solar or nuclear or wind. But so petroleum is still going to have to play a role. There are certain disruptors in this space as well, like for example the Teslas and so on, which are trying to electrify transportation as well, but there is still a long way to go there. And so that's the main message I want to get out, is that the transition is mostly happening in this space. So petroleum still has its applications, which are not being there are not many alternatives to that. Having said that, what we're looking at here is this is a annual energy report that's put together by JP Morgan, where they have this annual energy outlook. So what they're saying is that many of these forecasts about renewable energy so far have been overly optimistic. Like, for example, if you look at this like Clinton Presidential Advisory Panel, they were forecasting that by around 2020 or so, 50% of the energy consumption is all going to be renewable. But the reality is that we are nowhere close to that. Some of this could be like wishful thinking. We just want to get off of fossil fuels and have more environment-friendly fuels, but we are not there yet. It's a long way. But one thing definitely all the oil majors are noting is that there is an increase uptake in this alternate energy source. So then that brings the challenge for these companies is what competencies and capabilities can a hydrocarbon company contribute to an alternate energy field? This is one of the biggest challenges for oil majors these days. This is from a gentleman named Alan Foam. He's a consultant geophysicist who publishes some YouTube lectures on these topics. I highly recommend check those out. But this is a very valid question, because oil majors like Exxon and Chevron and Shell, they have diversified into other industries in the past. Exxon was selling computers, Chevron was selling perfume, and they were into shopping malls and stuff. And in all this diversification effort, they have failed miserably. I mean, they didn't understand the business process very well. They knew oil and gas, but they didn't understand these other businesses. So they failed miserably. They had to get out of those businesses. And because of that, the corporate memory is pretty bruised. So they are very wary about getting into something that they really don't understand. So that's something block of them. So you can see that from some of the press statements, some of these energy company executives are saying, for example, Chevron is saying, yeah, we don't want to go into wind and solar because we think they're already mature technologies and there is not much we can bring and create share value for our shareholders in wind. And so this is one company. Not all, all the companies are across the spectrum, but this is a major concern, especially for the U.S. Companies. They are, in other words, they're sticking to renewable natural gas and hydrogen, things that they think they understand and they know better. So what is renewable energy? It's another name for biogas. I'm not going to go into that because this conference has discussed that at quite a bit of detail, and honestly, I'm not even the expert on this thing. And then when we look at this trade magazines, we also hear things like green hydrogen. And again, this has been discussed a lot. This is just for people like us who are on the periphery of these things and want to know what all these jobs mean. And now we know what they are. What is gray hydrogen? Blue hydrogen is you take the CO2 and put it back inside, and green hydrogen is all green. And BP is expecting that by 2050, and one of this, it's going to be 50% of it is going to be green hydrogen. So those are their forecasts. There's a long way there to go ahead. I'm going to leave it at that. The other thing that we keep hearing is about this bio feedstock co-processing. Again, this conference, I believe, has done this in quite a bit of detail on this. I'm not going to go through that, but Chevron just recently announced that they are using co-processing 2,000 barrels per day of feedstock. Having said that, all I would say, I'd like to say to young engineers and researchers is, by no means this is a mature technology. Several challenges still remain. So if somebody is interested in these technologies and want to research, there is ample opportunities. Then I go to the second item that we see, carbon capture, utilization, and storage. This is something that the oil and gas industry has been doing for a while, and we like to think that we understand this a little bit better. The idea is to lower the overall carbon footprint by capturing CO2 underground, and utilization of supercritical CO2 for enhanced oil recovery processes. So, like I said, carbon capture has been going on in the oil and gas industry for a long time. One of the first ones is this Val Verde natural gas plant in West Texas back in 1972, and this facility is still in operations, and it's still it's mainly putting CO2 down to get EOR. And I don't know, the next talks is going to talk about some of these things. So the CO2, for those who are not familiar with this, some of the right conditions, it can become completely miscible with oil in underground rock. And what that means is that in theory, you should be able to recover almost all the oil in the ground. You'll be able to get 100% recovery of the oil if you have complete miscibility and the right conditions. So that's a big incentive for companies to consider CO2 injection for EOR. And we look at in our consulting business a lot. We add reserves based on CO2 and injection and how that is performing. And use of CCS climate mitigation has the first thing started around 1996, and this is the Sleipner natural gas processing facility in North Sea. And they have been putting about 0.9 million tons of CO2 away since 1996. That's a long time. So what you're seeing here is a chart put out by Global CCS Institute showing all the different CCS projects across the world. There are quite a few of them in the US, quite a few in Europe and China, and also in the Middle East. So the way these CCS projects work is that they have occurred chiefly across low-cost opportunities. What that means is that these projects were already separating CO2 out of the methane as part of the standard industry practice, because that's what they're selling. Methane is what they're selling. So they were already doing that. So the additional cost of taking that separated CO2 and putting it into the ground is very, very minimal. So that was something that the industry was already doing it. So most of these projects in the US are like that, is where they are actually already separating the methane, the CO2 out of the methane. So other thing is that most of the CCS facilities rely upon revenue generated from CO2 for EOR process, because what happens is that it's really not very clear how to monetize the CO2 storage. There are a lot of discussions in the governments and regulatory agencies about tax credits and carbon tax and so on, but nothing is very clear at this time. So without a clear value that the company can put on the CO2 storage, it becomes very difficult to look for any EOR applications, and that's when it becomes for them. CCS projects, they require a lot of coordination activities. There are different pieces to this, and they have long lead times and major investment decisions. So any failure in any component can affect others. I'm going to talk about a small example of this in the next slide. And risk of leakage from geological storage is actually pretty small. It's almost, but it's not zero. So what happens is there are liability issues that who is going to take responsibility if there is going to be a leakage in the future? Is it the government? Is it the operator? And how they're going to mitigate? So those legal aspects are there, but nothing too bad that can't be resolved. So I'm going in this slide. I'm going to show you two aspects. One is a success story, which is the CO2 injection in the Sleipner field. This is the CO2 produced from the Sleipner field is injected into the formation, Utsira formation in North Sea. That's about 100 meters below the subsea depth. There's one CO2 injector, and the injected gas is 98% CO2. And it has been putting away almost 0.9 million tons of CO2 since 1996. So that's a long time. So it's been going on for a while. So, and the biggest concern is what is happening with the CO2 plume. Is it leaking? Is it going anywhere, or is it staying where it's supposed to be? And this question is being answered by seismic technology. The geophysicists would know about it, because there is a lot of data that has been released on this, and that's used for a lot of reservoir characterization and any new techniques in seismic. So, so this is one of the ways to look and monitor this CO2 plume. So that's a big success story. But then we cannot say, yeah, we have to go. This is a good example of that. Chevron's Gorgon project offshore Western Australia. They have been having a lot of challenges. It has been unable to lock away 80% of the CO2 emissions in the first 5 years of the project operation, which has a lot of contractual implications. This is a joint project between Chevron, Exxon, and several other big majors. So if they are able to do this, it's a big issue. And like I was saying in the previous slide, we do not know all the reasons for what the failures are, because it's still the root cause analysis is still being conducted. But one of the things that came is that the facility pressure maintenance system has been breaking down quite often. There has been sand clogging happening in the underground issue. If this is the case, then one of the professors in one of the Western Australia universities says that it's also very extremely important to pick the geology when you're picking the reservoir your CO2 storage. So there might be some lessons learned which might be coming out of this whole exercise, and we will get better at this CO2 storage as we go along. So that's what I have to say about carbon storage. Then the next thing, as I said, is the geothermal energy. So this is a perennial favorite on both sides. When I say both sides, I mean the conventional oil and gas industry people have been doing the conventional oil and gas, and also the environmental and the recyclable industry side, because this is environment friendly, the geothermal energy. So on geothermal, there is a lot of renewed interest and enthusiasm on geothermal these days. These are some of the numbers that you see on the internet. It's like about 35% of the global demand for heating can be 2050 is going to be from geothermal, and about 10% by about 2100. But when you look at all the petroleum engineering literature and people who are really optimistic about geothermal of late, what they have been saying is, with renewed focus and application of advanced technology, I'm going to show some of these advanced technologies in geothermal industry, could be transformed drastically as oil and gas was transformed at the turn of the 20th century. That's a big statement. I mean, oil and gas at the end of turn of the 20th century was a big, huge boom, and it led to a completely different petrochemical society. So if that happens, that would be a really great thing. That can change the game quite a bit. But there are some enabling technologies to that. One of them is previously geothermal electric plants were built around tectonic plates, where it was you had to go for high temperatures. But this is one technology. This is one enabling technology, that is the binary cycle power plant. What this does is it increases the range of these geothermal projects. It can let you go and do geothermal at places like where the temperatures are lower, and the greenhouse gas emissions of geothermal are lower. So this is one of my key takeaways for this talk. Based on skill sets, geothermal offers a natural transition for oil and gas industry professionals. So what that means is that, the shale boom has made major improvements in hydraulic fracturing. So when you look at this enhanced geothermal systems, what you're doing is you're injecting cold water, and based on these improvements in shale boom, you get these major hydraulic fracture networks, and then extract the heat and produce it back to the surface and generate your heat. So, so that shale hydraulic which extend the range over the previous geothermal systems. Other technology that is really a game changer is this improvements in horizontal well drilling and directional well drilling. So what that does is that has applications in something called closed loop geothermal development. What it is you inject, you have an injector here, you have a producer here, and they are both connected and it's closed. So there is no fluid going into your formation, and it's all a closed system. So you can, so there is no leakage to the system. You just extract the heat, and then you can circulate the fluid. You can use not just water, any other fluid which is useful. And you can have different kind of setup too, where you have from the single pad, you can inject, you can drill your producer and injector, connect them up, and these are different types of the formations. So these are all advances in the horizontal well drilling which are being applied into geothermal, which can improve the geothermal systems. So although offshore industry made great strides in high pressure, high temperature technology, which is has direct applications there. Also, heavy oil steam assisted gravity drainage has applications, because they developed high temperature submersible pumps, downhole control devices, thermal casing, coil tubing, specialized cement. So all these can be applied into geothermal. So that's why some of the industry sources are pretty optimistic about geothermal. This is the forecast of the new geothermal well drilling. These are projects in sanction, and these are projects which are under sanction. So that's a good sign. Move on. What the pandemic did really is it has accelerated all these trends and more. So pandemic, first and foremost, is a humanitarian challenge. I wanted to say was, but I would say it still is. US was largest producers during the pandemic, but who can forget this negative oil price event that happened in the last middle of last year. So what this has done is it has reduced the investments in oil and gas drastically. They are down to 2005 levels, and they think that it will take 2025 to get back to previous levels. People must have seen this picture about the India Gate. This is during lockdown, and you can really have a good view of that. And what this has done is it's also reduced the commute, so that oil has gone down. But one other thing that it did is it increased the e-commerce demand by 2 to 5 times. So that's one of the effects. So I'm not going to go through this slide, but it's just increased the volatility in the market, and the prices are going to be going up and down quite a bit because of all these short-term impacts. Finally, the last point that I want to say is about data analytics and complex reservoirs. This is a very popular topic, and it's discussed in all areas, not just petroleum engineering, big data, machine learning, and AI application. There's some certainty in the midst of all the uncertainty that you're seeing in the previous slide. So this is something we understand, complex reservoirs we understand very well, and we've gotten good over the years. And when we say complex reservoirs, the first thing that comes to mind is shale. Shale has fundamentally reshaped the upstream industry structure. I'm not sure if any people recognize this gentleman over here. People talk about Mark Zuckerberg and Steve Jobs as technical entrepreneurs, but this person is George P. Mitchell. He was very instrumental in the shale revolution. So multilateral wells, multilateral hydraulic fracturing, completion design, these are all that have been improved. And that has drastically changed the shale scenario. It made US a net exporter of oil. What it has also done is flattened the production curve. What that means is back in 2009, if you wanted to bring new production, it would cost you like almost $100 per barrel. But now you can increase new production, but your cost will remain the same. So this has geopolitical implications, so also implications for renewable energies. And data analytics plays a big part in this whole transformation. Data analytics could be physics-based or data-driven models. So just not shale, data has applications all across the stream, in upstream, in geosciences, reservoir drilling, completions, production, and facility. So when you talk about big data, data analytics, machine learning, all these are words that are thrown around. But what we're trying to do is we're looking for relationships that otherwise would have been missed. So that's what it is. And this requires different skill sets. This various referred as upskilling or career pivoting on statistical based languages such as R and Python. So the gains from data analytics are real. Devon reported about 250% increase in their production by using these data analytical techniques, and they reported about 40% reduction in their drilling and completion costs since when they started this data analytical process. So data analytics has a very input into this complex reservoirs, and it will keep continuing to do so. So that will bring me to the end of my talk. In summary, these are the 5 big trends. The first one is energy transition, shifting to cleaner but recyclable sources. Carbon capture, so we're trying to do lower the overall carbon footprint. Geothermal, it's a good synergy with existing skill sets in the oil and gas industry. Pandemic is accelerating the changes which were already underway before that. Data analytics and complex reservoirs, I think this will remain a key focus in the short term. So that's my summary for the 5 things. And these are a few takeaways that I have for any younger engineers which are starting off in this industry. This is advice that my first boss gave me when I started here. He said, just plan for long term, acquire eligibility to work because it's an international business, get your industry certification, be actively involved in SPEs and AAPGs, learn something about entrepreneurship that's big these days, and you are in this for the long term, so take it steady and avoid burnout. Thank you and good luck. Any questions?
Thank you so much, Dr. Padmakar, for such a nice talk. Now I would like to participants to have some questions. Sinaji.
Thanks, Dr. Padmakar, for this very nice talk. When you were talking about this CCUS, when we think about CCUS in India, here also there are a lot of research activities going on in this CO2-based EOR. But when we think about the amount of crude oil that we produce, it's 20% and rest of 80% we import, and the huge amount of CO2 that we generate. So what do you think about, in that case, economy of CCUS project?
Yeah, that is an excellent question, Dr. Satish Sinha. It's not just in India; it's across the board, especially if it's not mandated by your government. So, like for example, in the Middle East, in Qatar or some of these other countries, it's the government which runs the whole. It's regulated by the government that you need to do this. But other economies where it's more capitalistic driven, you have to make some profit out of what you're doing. Unless there is I think some of the new conference is going to happen next week in Scotland, and they might have some clarity on some of this carbon tax and on. So once you have those clarity around how you can monetize CO2, I think you can have a business model around it. Otherwise, it becomes, in US is different that way because when they do EOR, you actually get the CO2 from the underground and you inject that. You're pretty much out of that. So, but if you have to take the CO2 from the industrial gases, separate it out, and then inject it out, the separation is one of the big cost elements. And so that kind of puts a damper on the economics of the projects. So so tax credits would help, I would say. That's my 2 cents on that.
Yeah, another thing about geothermal that I was thinking about. It's when people are doing this hydraulic fracturing for shale gas, there's always hue and cry for this induced seismicity that we talk about, right? And
That's correct.
yeah, and then when we start do this hydraulic fracturing for geothermal energy, and that too on a larger scale. What do you think about that?
Oh, yeah. I mean, I think there is a little bit of a misconception. I'll be clear that misconception of seismicity due to hydraulic fracturing itself. There is seismicity during the entire the shale operation spectrum. And you might have seen some news items coming out of Oklahoma and some other places. But they are very quick to clarify. A lot of that is not the hydraulic fracturing operation itself, but it's just the produced water or some other piece of the whole system, which is which is what is causing it. So the hydraulic fracture operation itself is pretty controlled, but I agree that the technology has not fully transferred over into geothermal, and all these other twists and turns are not being explored properly. But as far as hydraulic fracturing shale itself is concerned, I think this is my opinion, but I think it's been a little bit overblown than what exactly it's been happening, and a lot of it is some of it is produced water. So if you manage your produced water injection like you should, some of these issues should go ahead. And I'm very enthusiastic, by the way, about the closed loop thing, where you're not even dealing with any fluids going into the formation. So yeah.
Yeah, good. Thank you.
Are there any more questions? Just Lokesh, can you check in the participants? There is one Q&A. So, if there are no questions, I would like to formally thank you, Dr. Padmakar. Engineering. I often see in the data analytics presentation that says data is new oil. That tells us that what oil is actually to us. The
Yeah.
backbone of. So I understand it's going to be here for some time at least, and you people are involved in seeing that and how it can be useful in near future.
The only thing I will say on that one, Dr. Shukla, is that you have to be very careful between the hype and the reality. There is a lot of hype around some of these applications and artificial intelligence, this and that, but reality is a lot different, and it's a lot more. I mean, in a way, we had been doing data analytics work in the oil and gas industry for a while. It's just that I would like to say that other fields are just now catching up on that and putting some buzzwords, industry buzzwords on top of that. But yeah, we had been doing this. We deal with a lot of data, like the seismic data and a lot of that other things. So yes, we are very familiar with data, and it's definitely the new oil, I guess. Yeah.
Thank you so much for putting us the insight on the topic. Thank you, Dr. Padmakar.
Thank you.